You're an adult, somewhere in Neolithic Anatolia, roughly 10,000 years ago, and you've just done something that should make you violently ill. You've drunk milk. Not your mother's. You were weaned from that years ago, and your body quietly shut the door on digesting it the moment you stopped needing it, the same way every other mammal on Earth does. The same way every calf, every puppy, every human infant on record eventually does. You've drunk the milk of an animal you and your family keep penned near the village. And within the hour, your stomach is cramping, your gut is bloating, and you're heading for the bushes with a kind of urgency that has nothing to do with bravery and everything to do with a body that is actively, chemically rejecting what you just fed it. You do it again the next day anyway, and the day after that. Not because it's pleasant, not because anyone has told you it's healthy, or that it builds strong bones, or any of the tidy justifications you'd hear thousands of years later. You do it because the alternative, a bad season, a failed harvest, a family with nothing else to eat, is worse than a few hours of cramping. You do it because somewhere in your gut, underneath the discomfort, is a small, steady source of calories that doesn't run out as long as the animal stays alive. Fast forward to right now, and you're standing in front of a refrigerator door lined with a dozen kinds of milk. Whole, skim, oat, almond, lactose-free, and you reach for one without a second thought, because to you this is just breakfast. It's cereal. It's a splash in your coffee. It's the most unremarkable liquid in your entire kitchen. So ordinary you've probably never once paused mid-pour to wonder whether your body was actually built to handle it. And somewhere along the way, you probably absorbed a very specific, very confident idea about where that liquid comes from. Cows. Humans drink cow's milk. That's just what milk is, the same way water is wet and bread is made from wheat, a fact so basic it barely feels like a fact at all. Except that idea is almost embarrassingly wrong. And the real story is stranger, slower, and considerably more painful than someone milked a cow one day and everyone loved it. Let's get into it. Start with the assumption sitting quietly underneath the question, because it's doing more work than you'd think, that milk is naturally, obviously, something adult humans are supposed to drink. It isn't. Every mammal on this planet, humans included, is born with the ability to digest lactose, the sugar in milk, because every mammal starts life on milk. And every mammal, humans included, is supposed to lose that ability once it's weaned. The gene that produces lactase, the enzyme that breaks lactose down, is programmed to switch off after early childhood, quietly, without ceremony, the same way it switches off in a weaned calf or a grown chimpanzee or virtually every other mammal you could name. That's not a malfunction. That's the default setting for basically the entire class of mammals, humans very much included, stretching back tens of millions of years, long before anyone had ever thought to milk anything at all. You were born able to drink milk. You were never supposed to keep drinking it, which means for the overwhelming majority of human history, drinking milk as an adult wasn't a lifestyle choice. It was a mistake your body punished you for, every single time, with the same predictable, unpleasant consequences. Which means the real question was never, why cows specifically? The real question is far weirder and far more interesting. Why would anyone keep drinking a liquid that was making them sick for thousands of years, until their own bodies eventually evolved to catch up? Here's where the story actually starts, and it isn't with cows at all. Around 10,000 BCE, in the hilly landscape of what's now Turkey, human communities were shifting from hunting and gathering towards something new: settled agriculture, domesticated animals, permanent villages, a slower and more deliberate way of living than anything their ancestors had known. The first animals brought under human control for this purpose weren't cattle. They were sheep and goats, smaller, easier to manage, quicker to breed, less likely to trample a fence or gore a handler who got too close. Cattle came later, sometime around 8,000 to 7,500 BCE, genuinely a later chapter in the story, not the opening scene most people assume it is. If you'd asked someone in that first wave of Anatolian farmers what animal defined their relationship with milk, the honest answer would have had nothing to do with a cow. And even once cattle were domesticated, milk wasn't the point at first. These were animals kept for meat and hides, the same way you might buy a car mainly to get to work and only later realize it's also useful for road trips. Milk was, at best, a secondary bonus, and archaeologists can actually see the moment it starts becoming a deliberate resource because it's written into the pottery itself, sitting there for thousands of years waiting for someone with the right lab equipment to notice. Residue analysis on shards from the Neolithic period, some 7,000 to 9,000 years old, has turned up animal milk fats baked directly into the clay, direct physical evidence that people were processing dairy, whether or not they could comfortably drink it straight, which they mostly couldn't. And this is the part of the story that tends to get skipped entirely, because it's the least flattering. For thousands of years after humans started keeping milk-producing animals, most adults who drank that milk were, to some degree, poisoning themselves with it. Cramping, bloating, diarrhea. Not occasionally, reliably, every single time, because the biology hadn't caught up with the behavior yet, and wouldn't for a very long time to come. Because raw milk wasn't the only option, and someone, somewhere, figured that out by accident. Left alone under the right conditions, milk doesn't just spoil, it transforms. Bacteria break the lactose down before it ever reaches a human gut. The result is yogurt, cheese, kefir, foods with a fraction of the lactose of fresh milk, sometimes almost none at all. Early dairying communities weren't drinking glasses of milk at breakfast the way you might. They were fermenting it, culturing it, turning a substance their bodies rejected into forms their bodies could actually tolerate, through a process nobody at the time could have explained in terms of bacteria or enzymes, but everybody could clearly see worked, generation after generation, well enough to keep doing it without ever understanding why. The technology came before the biology. People engineered a workaround for a problem evolution hadn't solved yet, and it would take thousands more years before evolution caught up at all. That workaround mattered because it kept dairy animals valuable even to populations who couldn't drink milk without consequences. And valuable enough, apparently, that some populations kept drinking a little of it anyway, discomfort and all. Maybe because a bad stomachache beat starving during a lean season. Maybe because a mother with no other option gave watered-down milk to a weaned child rather than nothing. Whatever the exact reasons, somewhere in those populations, something started shifting at the level of DNA itself, quietly, generation after generation, long before anyone could have known it was happening. A change so slow that no single lifetime, and probably no single century, would have been long enough to notice it occurring. Around 8,000 years ago, a genetic mutation started appearing that would eventually rewrite the rules entirely. A change near the lactase gene that kept it switched on, permanently, well past childhood, for the rest of a person's life. Scientists call this lactase persistence, a name that sounds clinical for something that quietly rewired an entire species' relationship with food. And it's one of the strongest, fastest-moving examples of natural selection ever documented in the human genome. A claim that sounds like an exaggeration until you actually look at the timeline and see just how recent and how sudden this change really was. Fastest is not an exaggeration. Ancient DNA from European skeletons shows the mutation was still rare, barely present. Deep into the Bronze Age, thousands of years after cattle, sheep, and goats had already been domesticated and milked across the continent. You could dig up the bones of a farmer who had spent an entire lifetime tending dairy animals, and more often than not, find no trace of the mutation at all. A bit like discovering that someone who commuted by car their entire career never actually had a driver's license. Then, starting around 3,000 years ago, its frequency exploded. In genetic terms, that's not a slow drift. That's close to the fastest documented rate of positive selection anywhere in the human genome. A trait going from rare to common in a span so short that on the usual timescale of evolution, it looks almost like cheating. Think about what that timeline actually means for you, sitting here with a fridge full of milk you've never once worried about. Humans were drinking milk, fermenting it into cheese and yogurt, building entire economies around dairy animals for thousands of years before most of them could digest it comfortably as adults. The culture came first. The biology sprinted to catch up afterward, and even then only in certain populations, in certain places, for reasons still being pieced together region by region. Because here's the detail that quietly demolishes the humans drink cow's milk framing entirely. Cows were never the only animal in this story. And in some of the places where lactase persistence shows up earliest, they weren't even the main one. On the Eurasian steppe in what's now Kazakhstan, the Botai culture was milking horses, an entire pastoral society built around mare's milk long before cattle dairying had spread anywhere near that region. Something worth remembering the next time you assume milk and cow are basically synonyms. Herders across Mongolia, the Alps, the Middle East, and East Africa were working with goats, sheep, camels, yaks, water buffalo, even reindeer, each population adapting the same basic trick to whatever animal their landscape actually gave them. Nobody sat down with a checklist of mammals and picked the cow as the winner, the way you might scroll through streaming options for 20 minutes before settling on the same show you always watch. Geography picked for them, and geography handed out camels in the desert, yaks on the plateau, reindeer in the Arctic, and cattle only in the handful of regions where cattle happen to thrive. In parts of Mongolia today, dairy remains central to daily life despite the fact that researchers still haven't found the genetic mutation for lactase persistence in that population at any meaningful frequency. People there process dairy anyway, likely with help from gut bacteria doing part of the enzyme's job, a completely different biological workaround, arriving at the same practical result through an entirely separate route, like two coworkers independently solving the same spreadsheet problem without ever comparing notes. Cow's milk isn't the ancestral milk of humanity. It's one regional answer among several in a much larger, messier, worldwide experiment in which different populations, isolated from each other by oceans and mountain ranges, all landed on some version of the same idea. Find an animal, take its milk, and figure out how to survive drinking it. If your own ancestors happen to come from cattle country, that's an accident of geography, not a sign your body was somehow the intended target of evolution's design. Even the genetics back this up in an almost embarrassing way for anyone attached to a single, tidy origin story. Lactase persistence didn't evolve once and spread outward from a single point, the way you might imagine one lucky mutation sweeping the globe. It evolved independently, multiple separate times, in different populations on different continents. At least 5 distinct genetic variants have been identified worldwide, each one arriving at the same functional outcome through a completely different mutation, in a different gene region, at a different point in time. Europeans, East Africans, and Middle Eastern populations didn't inherit the same fix from a shared ancestor passing it down the family tree. They each stumbled onto their own fix, on their own timeline, because they'd each independently backed themselves into the same evolutionary corner, dependent on a food their bodies weren't built to handle, and under just enough pressure to eventually solve it. You didn't inherit a human trait. You inherited one of several unrelated patches applied independently to the same design flaw. The archaeology backs up just how desperate and inventive that patchwork was, long before any of the genetics kicked in. Researchers studying dental calculus, the hardened plaque that builds up on teeth and traps microscopic protein fragments for thousands of years, have found direct traces of milk protein on the teeth of people who lived in Bronze Age Europe and Southwest Asia, individuals who by every genetic marker available should not have been able to handle dairy comfortably, and drank it anyway. In what's now Germany, archaeologists excavating children's graves found small, whimsical, animal-shaped pots with narrow spouts, clearly designed for feeding infants, and testing confirmed cow's milk residue inside them, evidence of parents trying to keep a weaned or motherless child alive on whatever milk substitute they had access to, spout shaped like a tiny animal face and all, thousands of years before anyone understood why some children tolerated it and others didn't. And today, that patchwork is still exactly that, a patchwork, not a universal upgrade. By most estimates, somewhere around 2/3 of the global adult population remains lactose intolerant to some degree, which means the version of humanity you probably picture by default, glass of milk in hand, without a second thought, is actually the minority, the dairy equivalent of assuming everyone in the world drives on the right side of the road because that's what you grew up with. In parts of East Asia, lactose intolerance among adults runs as high as 90 to 100%. In much of sub-Saharan Africa, outside specific herding populations, the numbers look similar. The picture you probably grew up with, milk as a normal, universal adult food, is actually the regional exception, not the rule, concentrated heavily in populations with deep histories of cattle or dairy pastoralism. Northern Europe, parts of the Middle East, and select herding populations across Africa. Most adult humans on the planet, right now, today, are biologically closer to that Neolithic farmer doubled over after a glass of fresh milk than they are to someone with a bowl of cereal and 2%. If you've ever felt slightly betrayed by your own body after a milkshake, or quietly assumed something was uniquely wrong with your digestion, you weren't the anomaly. You were, statistically, closer to the species-wide default than the people around you who never gave it a second thought. Which reframes the entire question you started with. It was never really, why do we drink cow's milk? It's closer to, why did a small number of specific human populations staring down a food source that was actively making them sick decide the payoff was worth thousands of years of discomfort while their own biology slowly, unevenly caught up? The honest answer is calories. Reliable, storable, weatherproof calories in a world where the next harvest was never guaranteed. A dairy animal doesn't just die once and feed you for a week. It keeps producing, day after day, season after season, as long as you keep it alive, turning grass you can't eat into food you can. That kind of steady, renewable food source was worth an enormous amount to communities living one bad drought away from famine. Worth enough that some populations apparently kept drinking milk or feeding it to wean children who had no better option, discomfort and all, for generation after generation, until the mutation that finally made it painless had enough carriers, in enough places, to spread. We don't know exactly why lactase persistence spread so explosively once it appeared, and researchers are still debating the details region by region: famine resistance, calcium absorption in low sunlight climates, simple caloric advantage during hard years. What's not in dispute is the shape of the story: biology chasing behavior for thousands of years rather than leading it. And once that biology caught up in a given population, the payoff reshaped entire civilizations, not just individual diets. Across the vast Eurasian steppe, nomadic pastoralism, herding sheep, goats, horses, camels, yaks, even reindeer, became the economic backbone of one empire after another, from the Xiongnu Confederation to the Mongols centuries later. Dairy wasn't a side dish for these societies. It was closer to fuel, a food source mobile enough to travel with an army, resilient enough to survive a season with no crops, dense enough in calories to keep entire populations moving across landscapes too harsh for farming. You can draw a fairly direct line from a Bronze Age mutation near a single gene to the logistics that let mounted empires cross a continent without needing to stop and plant anything. Meanwhile, in regions where that mutation never took hold, or took hold only partially, dairy still found a way in, just never as a glass of milk on its own. Which is worth sitting with for a second, because it flips the usual assumption about who won this particular evolutionary story. It wasn't the cultures that drank the most milk who came out ahead. It was the cultures that figured out, one way or another, through fermentation, through gut bacteria, through a genetic patch, through sheer trial and error passed down for generations, how to get the calories out of dairy without the biology fighting back the whole time. So the next time you pour milk into your coffee without a flicker of hesitation, understand what that casual, automatic gesture is actually resting on. Not a universal human trait, not an ancient, singular bond between humanity and the cow specifically. You're looking at the tail end of one of several separate genetic patch jobs, each one built under pressure, each one arriving late to a food humans had already been eating, carefully, painfully, inventively, for thousands of years before their bodies gave them permission. The cow was never really the point. Cattle just happened to be the animal that ended up dominating the story in the specific corner of the world, Northern Europe, and the cultures that spread outward from it, that eventually exported its diet, its dairy industry, and its assumptions about what normal food looks like across most of the planet. A different set of migrations, a different climate, a different set of animals surviving in a different landscape, and you could just as easily be pouring fermented mare's milk into your coffee this morning, wondering why anyone would drink the stuff from a cow. The point was never the animal. The point was a species that kept eating something that hurt it, generation after generation, patiently waiting out its own evolution, and one, unevenly, in patches, region by region, animal by animal, still not finished even now. If you're one of the 2/3 of the world that still can't drink a glass of milk without regretting it within the hour, you're not broken. You're default human. Tell me in the comments whether milk agrees with you or not. I want to know how the genetic lottery actually landed in this room.